Hello and welcome to our video where we will dive into the data science query assistant, which is a powerful tool built using Streamlit, Cohere, Eden AI, and Spacey. This application is designed to answer your data science questions, generate quizzes, analyze CSVs, datasets, and facilitate dynamic conversation using information from specified websites. So let's get started by exploring the core functionality and the code behind them. So first of all, we'll talk about setting up the environment. So our project basically begins with importing necessary libraries and setting up environment variables for our LLM models, which is Cohere and Eden API. So there you can see I have established the API keys here. So if you want to get API keys for yourself, you can easily get it just if you go to their website. So yeah, so here you can see you can build conversational apps with RAG using this, and you can just click on get your API key and log in with your GitHub ID, and you'll be able to get the API key for yourself. And similarly, you can get Eden AI, which is also a really good AI model. So this is also what you can just sign in and get APIs for your models. It's a really good model. It's also available for generating videos and image generation. So I'm thinking of using it in my further projects. So coming back to the code. So just make sure you safely import the API keys here, otherwise it will not work. So the first thing is like defining to get your model to initialize. So you can see here I have initialized my model. So I've set the temperature to 0.75 and max tokens to 800 because I have to generate a lot of theoretical text for the queries, so I've increased it. Otherwise you can keep it low. So here what I have done is I have created a prompt template using LangChain. So here you can see there I have imported a prompt template from LangChain. So what prompt template does is that it's already give a basic template to your model where you don't have to enter a full sentence every time you're going to ask something. So here you can see as a data science teacher, could you explain the concept of topic? So here topic is basically a variable which only you'll be typing here. So here if you type in anything, that will be sent as a variable topic to the prompt template. See. So you can see how it does, and you can also play along with the code by telling the LLM to provide more information and also give code example. Right now I've commented it out because it was getting out of tokens because of I've used a trial API for that. So this is basically another prompt template that I've used to generate quizzes for the query model. So here you can see I've given it a basic uh, prompt, generate 3 questions answers on the topic, and this topic will be given as the variable which you'll type in. And here I've given example format and how the question and answer should be given. So here I have defined the basic functions to get response from the model. So here I've initialized the getCohere model, which is this function called this function, and then I've given it the prompt and I've set the prompt into the chain. So then it will give out your response. So this function is used for getting the response. And similarly, I've defined a response function for quizzes. Now, after the quizzes, what you can get is, you can see, get detailed explanation for key points. So basically, for building the flashcards, uh, it was a tricky part to be what I can say to build a flashcards, because the flashcards were going to be built from the response what the model will give out as a response, and from that response we'll have to select like the key points to be built as a flashcards, and then these key points will be sent back to the model to give out response. So this is what I have done to get response. So here I have developed this function to get detail. So here I have set a prompt, explain in 2 lines for building a flashcard, and then I'll give the key point which is being extracted from the first response of the model. So based on this, so you can see the flashcards are being generated. Okay, so then I'm sending this prompt back to the model with the key point, so it will return the response. So this is a basic function for generating flashcards based on the key points. So I have declared flashcards as an array, and for every key points in the key points that have been extracted, I have sent it uh, to the get detailed explanation function, which is here, and it will get the response automatically. So one thing that I've used to parse quiz questions from the response is, like, I have given basically so here I'll show you. I have given the LLM a format in which it will send out the quiz questions and answers, and there, in parsing the quiz questions from the response, I have set the same format in which the quiz questions will appear, and then after that it will just parse the questions and answers apart from the response and set them in a flashcards. So this was a bit tricky, and for this I have used a library called Spacey. Here you can see Spacey. So it's a really useful library for NLP parsing and everything. So it has very different models. So this is how you can use Spacey in any of your projects. So okay, so here are different guides of Spacey. From what you can do is embedding, transformation, LLM training models, layers, and architecture. So I've used the Spacey's parsing and embedding model here, so that it can just take out the given key points from the response every time. So which is what I've used, and also for generating flashcards I've used the Spacey's model. You can see, and Spacey.load encode web sm. So it basically parse the text and then dig out the keywords that you have mentioned. So here I have mentioned few of the data science keywords here. You can see. So wherever this model sees this word in the response, it will uh, take out these words and send it back to the model and then generate flashcards based on that. So this is how I've generated flashcards. So this is exactly the same function which I've used for flashcards, and then displaying the flashcards in Streamlit with using containers. You can see. So this is a very basic thing which is used in building Streamlit UI that I've used, and similarly the same for quiz flashcards. Now this is what Streamlit UI that I've used here. So I have used Streamlit st.chat module, which is a very new module in Streamlit, which is used to build chat-based apps, uh, which wasn't previously in Streamlit. So that's one good improvement in Streamlit, I would say. So this is the basic UI outlet that I've built. These are the tabs, and this is the basic display message that will be displayed. And here I've used a session state, which is a function in Streamlit that keeps your state active, uh, because in Streamlit every time you click a button, Streamlit refreshes and rereads your script every time. So that's a downside of Streamlit. So for that you can just use session.state, and then that script won't run beyond that function. Okay, now coming to the next thing, that is building uh, the CSV file reader for analysis. So here I've used the Eden AI model. Here you can see, here I've initialized the Eden AI model. So it's basically provided by OpenAI, and it used GPT 3.5 Turbo Instruct. So it's a really powerful model, I would say. And here I've defined the function to get basically output, and defined the chains from LangChain to get the output for the CSV files. I have given verbose equals to true here, and this is the uploaded file that will go into the LLM, and here the model that I've used. So basically this creates CSV, that's import of LangChain. Here you can see, this is where I have imported LangChain from LangChain experimental agents. So this is basically a LangChain agent which is used to interact with the CSV files. So it was a pretty easy implementation. So here you can see in the tab 2, this is the UI that I've created. You basically upload a file, store it in a variable, and then give that file uh, to the model. And here I've made a query variable which you can type in any question, and that will basically go to the LLM for analyzing. So yeah, here I've called the get answer function, in which basically you'll get answer from the agent, and you have to use agent dot run to run any query to the LLM from the file. You use this uh, agent dot run every time. So this is how the second part was built. Defining functions from RAG website chat. So this is where I have implemented uh, the retrieval augmented generation based uh, functionality in my project. You can see where it retrieves the data from the website and split it into text and give you the output. So I'll show you how it was built. So for these I've used embedding function. Here you can see embedding is used. You can also use OpenAI embedding if you have that, but I was using the free open source embedding which LangChain provides. So you can basically import these embeddings here, and this is the model name that is used for the embedding. And here you can see I have imported this from LangChain. And after that I have created a vector store uh, which basically create vector stores of on the given URL and loads the document, and then it splits the document into chunks, so it doesn't take the whole document as in one, because it will be very high in computational resource if the model has to go through document each time. So it splits that document into chunks of documents, and then based on the keywords it finds the right chunk of file and then provides the answer from that. Okay, so again for that I'm using Cohere LLM. You can see I've initialized the Cohere, and so you can see here I've given a prompt uh, to this retrieval chain, which you can just see user input. So input will be taken as what you write in the text box, and then given above the conversation generate a search query to look up in order to get the relevant information to the conversation. So this is what basically a prompt I've given it uh, to the LLM so that it can get basic details of your question searched. And then I have initialized the retrieval chain. So it takes 3 arguments here: LLM, the retriever, which is the vector store, and the prompt. So after that it will just return the retrieval chain. Now coming to the next function is that get conversational RAG chain built. So again you will just use LLM model here, define your model and provide a prompt as before from chat prompt template. So here you can see answer the user's question based on the context below. So the context, and then it will place it in the chat history. So context is basically what the context is basically what it will be given to the prompt based on the link. So it will automatically know like what is the context of the question based on the website, and you don't have to give context to your model before asking any question related to that website. And this is a basic function to just get response from the LLM. And there I have built this UI for the website URL tab. It's a very basic UI image which I've used the chat functionality of Streamlit to build that. Yeah, so this is how the code works, and I would like to know your feedback on this. And like, yeah, there you have it, our data science query assistants with equipped with AI-driven explanation, quizzes, CSV data analysis, and website chat functionality, and all made possible with Streamlit, Cohere, Eden AI, and Spacey. This tool is basically a test statement to the power of combining different AI and NLP technologies to create an educational and interactive experience. And thank you for watching my video. You can dive into the code and experiment it with or play along with the code. Try making changes, try using different LLM models, and see how different results you get. Yeah. So yeah, that will be all. Yeah. Thank you.